Hello friends, today we'll be looking at light dependent resistor, otherwise known as LDR, light dependent resistor. So this resistor, just like every other normal variable resistor, the resistance can be varied. But the only difference between this resistor and just ordinary rheostat is that the resistance of this LDR can only be varied by light. It can only be varied by light, which means it's only the brightness of the light that determines the resistance of this resistor. So you can vary the resistance of this particular resistor within its rated range using a light. So some of these LDR, some of them are rated 10k, that's kilo ohms. Some of them are rated 100 kilo ohms, depending on the one you have. But all of them has the same type of construction and usage. If you look at it very well, you will find out that it has this kind of arrangement on it, on the surface of the LDR. It has this kind of arrangement. So that is how you know the LDR when you want to get one. So though the sizes might differ, but all must have this kind of shape. So this is the schematic representation of the LDR. In the diagram that you see, this arrow shows that the light is falling on it. That's what it shows. So it shows that the light is falling on it. So it varies with the intensity of light. So which means you can use this profitably when designing a circuit that can operate in a particular manner at night or when interfaced by any object. Just like line detection circuit, you can use LDR to build such a circuit. You can use LDR to build automatic light controller that switches on your light at night and switches it off in the daytime. So that is one of the basic things you can use this LDR for. So how do we even configure the LDR? Let's say we want to use this LDR to drive a relay to switch on our light in the night and switch it off in the daytime. So this is how this circuit will look like. This is the normal resistor, fixed resistor. Then this is the LDR. This is the LDR. And then let's say we are using a relay of 5 volts. A 5 volts relay. If you don't know how relay works, please check out the other video I uploaded some time ago. You will know how a relay actually works. So let's say we are using a 5 volts relay. So we want to use it to drive to either switch on or switch off our light. So what we do, we have the supply voltage here, that's 12 volts supply, and then let's say what we have here, this 100k LDR, 100 kilo ohms LDR, and this is also 100 kilo ohms fixed resistor. So if we do the simple calculation here, using voltage divider rule, you find out that what we have here now is 6 volts. So see the calculation here, see the formula here. V out, and this is V out. V out is equal to R2 over R1 plus R2 multiplied by the V, by the input voltage. That is how you get your V out, the voltage across here, across this terminal. This 6 volt I just said. Now if you want to calculate it out, this is the formula you use. If you substitute all these variables with these numbers here, you find out that you get 6 volts. Let's just say, okay, let me just show you. Basically, if you say the R1 is 100k, the R2 is 100k, remember this is the LDR and it's rated 100 kilo ohms. So which is our R2 now? This is our R2. This is our R1. So 100k divided by R1, which is 100k also, 100k also, plus R2 again, which is 100k. So let me write it to website to record there. Right. 100k plus 100k multiplied by 12 volts. That will give you the voltage across this terminal, and it's equal to 6 volts. So which means with this arrangement, the relay will be on. This will be the state of the relay. If this arrangement is connected to this 5 volts relay, the relay will be on. So the relay, this is normally open and normally closed. So with this arrangement, this relay is already on. That is why this terminal is normally open. So it's already on. So but what will happen here is that this is the state of the circuit at night. As it is now is the state of the circuit at night. What will happen as day breaks, as the sun starts to shine upon this LDR, which is what we have here, the resistance will keep decreasing. As the brightness of the sun comes up, the resistance will start decreasing. For 100k, it can come to, let's say, I've cleaned everything. From 100k, it can come to 90, 60, 50, depending on the intensity of the light. So before 6 a.m. or 7 a.m. in the morning, before 7 a.m. in the morning or thereabout, the resistance of this LDR must have been reduced up to 50 kilo ohms. Due to the brightness of the sun, it must have been reduced to up to 50 kilo ohms. Then, if you substitute 50 kilo ohms in the initial formula I gave you before, you find that what you have in the output here would be about 4 volts. And this 4 volts will not be enough to drive our 5 volts relay, which means the relay will go off, thereby switching off the light. So that is how it will continue to behave. So the light will be off because these 4 volts here will not be able to drive the 5 volts relay. So as days goes on, the sun keeps brightening up. So the LDR, the resistance of this LDR will keep going down and down until evening time again, when the sun starts going off, fading off. So as darkness is coming upon the earth, as day is getting darker and darker, the resistance of this LDR will keep increasing. Maybe it may have reduced to about 100 ohms, so it will keep increasing to 200, 300, 1 kilo ohms, 2 kilo ohms, 50 kilo ohms, up to 80 and back to 100. So once it reaches like 80 kilo ohms or about 85 kilo ohms, and that will be around 6:30, 7 p.m. in the evening time. That will be around 6:30, 7 p.m. or thereabout. You can adjust the circuit to fit any time that you want by just adjusting the values of the resistors you use here. So once it's around that kind 85 kilo ohms or thereabout, the voltage across here will be up to 5.2 or 5.1, thereby energizing the 5 volts relay back, and the light will switch on automatically. So this is how you can use the LDR to control your light automatically. Like if you have not seen LDR before, look down. Okay, let me show you how LDR look like. This is actually the structure of LDR and how it looks like. Okay guys, this is an LDR. So this is an LDR, light dependent resistor. So I'm going to show you how the resistance varies with respect to light. So now I've connected the two probe of this multimeter to this breadboard. So I'm going to plug in this LDR now. I'm going to plug in this LDR. So we'll see how it actually varies. Okay, you can see the readout on the multimeter. Remember, you put the multimeter, you set it at resistance range. So you can see it's reading 1.3 ohms. That is because of light. I'm outside now doing this video. I'm outside, so that is because of the intensity of light falling on the LDR. So the resistance across the LDR now is 1.3 ohms only. So see what happens when night start coming. Let me cover it with my hand to show you how it actually responds to darkness. See, as I'm covering it, the resistance is increasing. As I'm covering it, the resistance is increasing. See, as I'm covering it, the resistance is increasing. You can see this is about 8 something kilo ohms now. See it, it keeps increasing, keeps increasing, it keeps increasing. So if I remove my hand, resistance will reduce again. See, that is actually how the LDR works.